Okay, so we're going to go through the formal definition of what a parabola is. So by definition, the parabola is the set of all points in a plane that are the same distance from a given point called the focus, and a given line called the directrix. Okay, so just to give you a little bit of a visual, say this is A. Alright, so this is A units from 0. This is B units from 0. And over here I'll have this is C units from 0. And let's say here's my parabola. I'm going to draw a horizontal line through C. This is the line y equals C, and this will be our directrix. And I'm going to have another point with the coordinates A, B, and that will be my focus. All right, and what the formula is saying is that every single point on the parabola will be an equal distance from the directrix as it is to the focus. So to get from any point to the focus will be the same distance it takes to get to the directrix. That's what this is saying. And that works for every single point on that parabola. It is the same distance from the parabola to the focus as it is to the directrix. And that's all that's saying. All right, so we are going to learn more parts of the parabola. There's going to be quite a few. All right, next one. So we now know about that it has a focus, we have a directrix, we know that every point on the parabola is the same distance to the focus as it is to the directrix. Now there's going to be another new vocabulary word called the latus rectum. And what this is the line segment or a line segment through the focus perpendicular to the axis of symmetry. The endpoints must be on the parabola. Okay, so we know the axis of symmetry is a line that goes through the vertex. So in this scenario, it would have been a vertical line. So the latus rectum is a line segment that goes through the focal point. So let's say this is my focus. So it's a line segment that goes through the focus that is perpendicular to the axis of symmetry. So it would look, and its endpoints have to be on the parabola. So it would have to look something like that. Through here, that's our focus. And we get our right angles right there. Okay, so let's talk about all things we should know about the parabola. I'm going to list it all out. So I'm going to list this section as things to memorize. All right, so on the left side, I'll do everything in reference to the equation of a vertical parabola. So on this side, our equation will be y equals a times the quantity of x minus h squared plus k. So what are things we should know? First thing is our vertex, right? How do we represent the vertex with what comma what?
H comma K.
You got it, h comma k. The next thing is our axis of symmetry. How do we represent the axis of symmetry for a vertical parabola? Oh,
X equals H.
you got it, x equals h. All right, some new things. Our focus. In order to find the focus for a vertical parabola, what we're going to do is we're going to take h comma, because it's a point, right? H comma, then you take k minus 1 over 4a. That a is in the denominator. It's not 1/4 a. It's 1 over 4a. The a is in the denominator. The directrix is going to be y. This is a line. So the focus is a point. The directrix is a line. So the directrix will be the line y equals k minus 1 over 4a. Oh, sorry, guys. The focus should have been a plus. The directrix is a minus. Let's fix that. Once again, that a is in the denominator. All right, the length of the latus rectum is going to be the absolute value of 1 over a. Why do you think I have it in the absolute value lines? Why do we think it's the absolute value? Good. Length can't be negative, right? It's always going to be positive. Oh, and the last thing I forgot to say in the beginning was the direction of the opening. So remember, if a is greater than 0, we open up. If a is less than 0, we open down. All right, so that's all for our vertical parabola. Now we're going to do all this stuff for our horizontal parabola. So this equation is x equals a times the quantity of y minus k squared plus h. Right? Our vertex is the same. Our vertex will be h comma k. Because it's now horizontal, our axis of symmetry is going to be different. Our axis of symmetry will now be y equals k, horizontal line, not a vertical line. Our focus really hard to get somebody's attention. So to find our focus, we're going to have h plus 1 over 4a comma k. So it's different. Last time we added the 1 over 4a to the k. Now we're adding it to the h. To find the directrix, it's now going to be a vertical line, so it will be x equals h minus 1 over 4a. All right, the length of the lattice rectum is going to be the same. It's 1 over a units long. And lastly, the direction of the opening. If a is greater than 0, it will open to the right. If a is less than 0, it will open left. Okay, let's do some graphing. So I'm not sketching anymore. These are graphs, so it's going to be pretty involved. So I want us to graph So the first one will be y equals 1 over 8 times the quantity of x minus 1 squared plus 4. So this is nice because there's not really much manipulation here. So we have a times quantity of x minus h squared plus k. So I'm going to ask a series of questions. First one is the vertex. So remember, our vertex is h comma k, so we're going to have 1 comma 4. The next thing I'm going to ask for is our axis of symmetry. So our axis of symmetry will be x equals h, so it's going to be x equals 1. Also want to know the direction that the parabola is opening. Because my a is positive, we are going to open up. And these are all things we should be able to answer pretty quickly, right? All things we've had practice with. So now let's get into the new stuff. So the next one is going to be our focus. And if you guys just memorize the different sort of formulas for this, it makes it a lot easier. So we're h comma k plus 1 over 4a. So our h is 1, our k is 4, but then I'm going to have 4 plus 1 over 4 times the a, but what's our a? 1/8. Well, when I multiply 4 times 1/8, do we agree that's a half? So now I'm going to have 4 plus 1 over a half. Nope. Just one over there. Well, what's 1 divided by a half? 1 divided by a half. Isn't that keep, change, flip? So that's 1 times 2. So now we're going to have 1 comma and then 4 plus 2. So our focal point will be 1, 6. All right, now let's talk about the directrix. And to find the directrix, it's a line, so it's going to be y equals k minus 1 over 4a. So here I'm going to have y equals, go back, what's my k? My k is 4. So 4 minus 1 over 4 times 1/8. Well, didn't we just do that whole 1 over 4a thing? We just did it, and what did we get? Wasn't it 2? So we're going to do that again. So we have y equals 4 over 4 minus 2. So y will equal 2. We're not done. I want to find the length of the latus rectum. So that's going to be the absolute value of 1 over a. Well, that's going to be the absolute value of 1 over 1/8. Well, what's 1 divided by 1/8? 8, exactly. So I have the absolute value of 8, which is 8. Still not done. Last two things I want us to find are the x-intercept and the y-intercept. So x-intercept, we're letting y equal 0. So we have 0 equals 1/8 times the quantity of x minus 1 squared plus 4. I'm going to first subtract that 4. So I have negative 4 is equal to 1/8 times the quantity of x minus 1 squared. I'm then going to multiply that 8. So I have negative 32. And I'm going to stop here. Why do you think I'm going to stop here? Philip? Because we're going to square root a negative number, so we know there will be no x-intercept. And the very last thing we're going to find is the y-intercept. And for the y-intercept, we let x equal 0. So we have y equals 1/8 times 0 minus 1 squared plus 4. Oops. So y will equal 1/8 plus 4. Well, isn't that just 4 and 1/8, right? I would just leave it like that. All right, now we have everything we need to graph this. It's a lot of stuff. I know, it's tedious. No, why is it so small? Okay. You can bring graph paper. You don't have to. For the other lessons, I don't think you'll really need graph paper, but you should always have like a couple of pieces with you. Okay, so let's go. We have our vertex is 1, 4. Gotta go higher here. I'll put V for vertex. My axis of symmetry is x equals 1. Your axis of symmetry should be drawn as a dashed line. So there's my axis of symmetry. We then had our focus, which is the point 1, 6. Higher. So here, I'll put an F here for my focus. There's my focus. Then we had our directrix is y equals 2. So I go to y equals 2, and I'm going to draw a line there. This is our directrix. I have no x-intercept, which makes sense, right? Because our vertex is all the way up. And then our y-intercept is about 4 and 1/8. That's obviously just an estimation. So like right over here. Okay, so now when our lattice rectum was 8 units long, what does that mean? That means we're going to go to our focal point, and from edge to edge, it's 8 units. So from edge to edge of the parabola is 8 units. That means it's 4 units to the left and 4 units to the right. So 1, 2, 3, 4, we're over here, and then 1, 2, 3, 4, we're over here. And now I can draw my parabola. very wide parabola. So I just wrote it out in case you forget. So when the lattice rectum length was 8, that means it's 4 units on either side of the focus. All right, ready to try another one? Let's do another one. So do we all agree this is a pretty wide parabola, right? All right, let's look at one that's not so wide. So let's graph, number 2. Y equals 2x squared minus 1. So y will equal 2 times the quantity of x minus 0 squared plus 1. Why did I rewrite it like this? So it fits more closely to that a times x minus h squared plus k. Yes?
Isn't that -1?
Oh, it is -1. You're right. Thanks. All right, well, let's go through and find all the things we need to find. So first thing is our vertex. Our vertex is HK, so we're 0, -1. My axis of symmetry is going to be x equals h, so that's x equals 0. Which direction is this opening to? Up, you got it. All right, next thing we need to find is our focus. And our focus will be h comma k plus 1 over 4a. So my h is 0, then my k is -1 plus 1 over 4 times 2. So we're 0, comma, -1 plus 1/8. Is this a -1/8? 1 and 1/8? No. Right? If you want, you could make common denominator, and you'd get -8 over 8 plus 1 over 8. So that's going to be -7 over 8. Now we need our directrix. Now the directrix is a line, and this line is going to be y equals k minus 1 over 4a. So we're going to have y equals -1 minus 1/8. Is it safe to say that this is -1 and 1/8? How come this one was -1 and 1/8, but the other one wasn't -1 and 1/8? Tori? Good, because both these signs are negative. All right, so we got our directrix. Now let's go to the length of the lattice rectum. I'm just going to put LR. And that's going to be the absolute value of 1 over a. So this is going to be the absolute value of 1 over 2. So that's just a half. I'm going to find my intercepts. So the x-intercept, remember we let y equal 0. So where 0 equals 2x squared minus 1. So 1 equals 2x squared. A half equals x squared. Square root both sides. We are going to have x is equal to 1 over the square, plus or minus 1 over the square root of 2. Can I leave it like this? No. So what are we going to do? We're going to rationalize it. So we're going to have root 2 over 2, plus minus. We're going to have to estimate this. So how are we going to estimate this? Well, it might have actually been easier to estimate from over here before we rationalize. So we know root 2 is between root 1 and root 4. Square root of 1 is 1, square root of 4 is 2. So we're going to say about, what, 1.5? So now if we have 1 over 1.5, right? 1 divided by, what's 1.5 as a fraction? 3 over 2, thanks. So that's keep, change, flip, 1 times 2/3, which is about 1 times 2/3 is 2/3, right? So this is approximately plus or minus 2/3. All right, our y-intercept. Our y-intercept, we're going to let x equals 0. So we're back to y equals 2 times 0 squared minus 1. So y equals negative 1. All right, now we can sketch. All right, so our vertex is 0, negative 1. Put V for vertex. We're going to have our directrix, which was, what was our directrix? Negative 1 1/8. So we're going a little bit past the negative 1. We have our focus, which is negative 7/8. If we're negative 7/8, do we agree that's like a little before negative 1, right? So I'll go right here. That's our focus. Okay, so now the length of the latus rectum is a half, right? But that's the total length is a half. So what does that mean for either side of the focus? About 1/4. So that's like super close. And obviously I'm not expecting this to be perfect. Oh wait, I forgot my x-intercepts. Our x-intercepts were plus minus 2/3, thank you. So we're here and we're here. There we go. So it looks something, oops. Oh well, good enough, I think. Like something like this. Okay, what do I want to talk about? In comparison to the first one we did, is this more narrow or is it wider? More narrow. What decides how wide it's going to be? The length of the ratus rectum. And what is the length of the lattice rectum based on? A. So let's make a conclusion here. So A for the first one was, what was it? 8? 1/8. And what about A for the second one? 2. All right, so what are we noticing? When it was a whole number, wasn't it, or when it was a fraction, wasn't it wider? And when it was a whole number, wasn't it more narrow? So that's not a coincidence, because you're really doing 1 divided by whatever that A is. So something we need to know, if A is greater than 1, the parabola is more narrow, and if A is between 0 and 1, so A is greater than 0 but less than 1, the parabola is wider. And this is all in reference to the parent graph y equals x squared. So when I say it's more narrow, that means it's more narrow than y equals x squared. When I say it's wider, that means it's wider than y equals x squared. Do we have time to do a horizontal one? No. We have 5 minutes. That's no way. It'd take me that long just to write all the things we need to find. I think you guys could do it with just the formulas, though. So I think we're okay.